Welcome to 10th class mathematics. Let's learn the lesson coordinate geometry now. Okay, then we'll solve some problems for IOCM and other entrance exams. What I have seen is coordinate geometry in 10th class, it's in Telangana syllabus as well as ICSE and CBSE, is very limited. It's kind of opening course basically. Just to give introduction of what is coordinate geometry and how to do some basic problems in coordinate geometry. But most of the complicated problems and most important formulae, all those are coming in the 11th and 12th classes more, especially the 3D geometry. Most of the questions from entrance exams are from 3D geometry. But these are basics and very nicely put the lesson in coordinate geometry actually for Telangana class 10. So let's go through this lesson first and then solve some problems. Okay. So what we cover in this is basically introduction, distance between 2 points. Okay. Distance between 2 points on a line parallel to coordinate axis, then basically distance between any 2 points. Okay, then section formula, then trisection points, which is extension of section formula, centroid of a triangle, then area of triangle, collinearity, okay, then Heron formula, of course, then straight lines and the slope. Okay, so these are the very basics of coordinate geometry. Based on these, we do solve many more formulae we derive actually. So if once you are good with these basics, then anything is easy for you. Okay, so let's get into introduction first. Okay, so introduction. What do you see here is a chessboard, right? See a chessboard here. Okay, the question is, if you take a knight, what kind of steps it can do? Okay, if you are playing chess already, you know how knight can go. It normally takes two steps on one of the horizontal or vertical direction. Okay, then one step to the left or right. Okay. So a knight can go to A, B, C, D, E, F, G, or H. Okay. All these positions are possible for a knight. Now let's assume that this knight is on the coordinate plane. It is at the 0, comma 0, in the center basically. Okay. Now uh, from center, it can go uh, these steps, these 8 steps which are shown here, A, B, C, D, E, F, G, H, right? So what are the coordinates of these points basically? If you take this as 0, comma 0, obviously this is 2 units above, so y is 2, okay, and x is 0, correct? So and this side is -1, x is -1, x is +1. So A coordinates are basically -1, comma 2, B is 1, comma 2, okay, and here it is x is 0, uh, right? So here x is 1, x is -1. Sorry, y is 1 here, y is -1 here. So x is 2, 2 unit cells, right? So this is C is 2, comma 1, 2, comma -1. Okay, similarly E is uh, 1, comma -2 and -1, comma -2. Okay, this is -1, comma -1, comma -2, comma 1 and -2, comma say -2, comma -1, -2, comma 1. Okay. So these are the coordinates of A, B, C, D, E, F, G, H. So very easily you can derive once you assume that this is the x-axis, this is y-axis, and this is x-axis. It's very easy to find out. So if you see, can you also do for uh, uh, other pawns in the pawn and the knight, bishop, and other pieces in the chessboard, how they are moving? Just check it. This is they move by the coordinate plane basically, right? So if you consider this, if you consider this as 0, comma 0, then you have you can actually put the numbers properly for each piece how they move. Okay. Now the questions are Write down the coordinates of ABCDF. We just discussed about it. Find the distance covered by night in each of its 8 moves. That is, find a distance of A, B, C, D, E, F from the original position. Now, if we go back here, from A, how much is the from origin? What is the distance of A? How do you calculate? It is 2 units of uh, height, then 1 unit is left side, right? Left side. So it forms a right angle triangle here, and A2, if you call this as 0, O, basically OA is equal to, it's a right angle triangle, so square root of 2 square plus 1 square. 2 square, that is height, 1 square is length. Okay, minus 1 square otherwise. Okay, so 2 square, square root of 2 square plus 1 square is square root of 5. Okay, so each one is approximately same. This is also 2 units height and 1 unit. So you see each one is a right angle triangle. Length and breadth are 2 and 1. They may change here. Here length is 2, breadth is, I mean, you can call one side is 2, other side is 2. Sides may change, but they always remain 2 and 1. And you always want the uh, hypotenuse basically, right? So it will be a square root of 5. Okay, distance of all those things. Then what is the distance between 2 points H and C as well as A and P? Where is H and C? Let's check. H is here, C is here. So it is how many units away from C? 1, 2, 3, 4. Okay, so distance between H and C is 4 units. A and B it is 2 units. Correct? 1, 2. Okay. So this is how in a coordinate geometry, if I call it minus 1 comma 2 and 1 comma 2, the distance is 1 minus of minus 1, that is plus 1, right? 2 unit gap. And similarly, if you put the coordinates of H and C here, you can check the 4 distance how it has come. Okay, it is just a difference in x-axis, right? Y is the same. Here for H and G, you will get a difference only in the y-axis. Okay, so that is how we basically calculate the distance of 2 points on a coordinate plane. Okay, so just for information, in a coordinate plane, two-dimensional coordinate plane, we write it as x comma y, right? So x is called abyssa and y is called ordinate. Okay, so just remember it. This is not mentioned in this chapter, but that's one of the very basic thing we should know. X is called abyssa and y is called ordinate. Okay, so yeah. Now let's discuss the distance between 2 points. Distance between 2 points. Okay, let's go step by step how to find the distance between 2 points which are anywhere on the coordinate plane. First we will look at distance between 2 points which are on the axis. Okay, so if you take 2 points, A 2 comma 0 here, you can see. Okay, and yeah, A 2 comma here and B 6 comma 0. Okay, if you look at these are the points. Okay, mentioned here 2 and 6. So it is very clear that the distance between these 2 points is 6 minus 2, that is 4. Correct? What is 6 and what is 2? 6 is the x coordinate of B, 2 is the uh, coordinate of A. Okay. So let's say if these 2 points are on the other side of the axis, that is negative side of the x-axis, that is minus 2 comma 0 and minus 6 comma 0. Then what is the distance? You will say minus 6 minus of minus 2, which is minus 4. Or you take the absolute value because distances are not measured in q terms. So you will take absolute value of minus 6 or difference between the x-axis coordinates because y is 0 anyway. There is no change in the y-axis. Okay. Now similarly, if you take any 2 points on the y-axis, the x coordinates are 0, correct? So how do you measure the distance between them? Difference in y coordinates, that is 7 minus 2. Okay, and if they are in the negative plane also same, you will measure by absolute value of the difference between the two y coordinates. because x coordinate is 0 for both of them. Okay. So this is how you measure distance between 2 points which are on the axis. Okay. Now let's go, let's just do a simple exercise. Where do these points lie on the coordinate plane? Minus 4 comma 0 and 2 comma 0, where y coordinate is 0. Correct? Y coordinate is 0. So they lie on x axis. Correct? They lie on the, suppose minus 4 comma 0 is here. It comes here. Okay. And 2 comma 0 is here. Okay. 6 comma 0 here. Minus 8 comma 0 is here. Okay. So these are the points for this one. Find the distance between minus 4 comma 0 and 6 comma 0. Okay. So minus 4 comma 0 and 6 comma 0. So it is just very simple. Difference between them is 6 minus of minus 4, that is 6 plus 4, which is 10. Correct. And between minus 4 and minus 8, minus 8, minus 8, minus of minus 4, that is minus 8 plus 4, that is minus 4. You take the absolute value. So distance is 4. Okay, you can count from here, right? 1, 2, 3, 4. It is just 4 units away. Minus 4 and 6 are 10 units away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So what we need to do, for if the points are on the same axis, then we just a difference of the x coordinate or y coordinate, which is non-zero, we should calculate. Okay? Now, distance between 2 points on the axis is done. Okay. This is for the y-axis, basically. Problem on the y-axis, they lie on the y-axis, and difference is again difference between the y coordinate. Okay. Now, how will you find the distance between 2 points in which x or y coordinates are same but not 0? Okay. So this is a question. Just to think about it. You have 1 comma 1 and 2 comma 2. Let's say. How do you find? Okay. So we will slowly go to that level where we can find a distance between any 2 points. Think about it. If you see the graph, actually, it's very easy to understand. Uh, if both x and y values are same, it will be something here, and let's say something here. So it definitely forms a right angle triangle very easily. You can form a right angle triangle, measure the uh, distance of this one, length, I mean, two right angle sides. Then we can easily calculate the hypotenuse. Okay, we will do more of those examples. Now, distance between 2 points on a line parallel to the coordinate axis. So, in this case, the line, the 2 points are parallel to one of the axis, either x-axis or y-axis. That means their y coordinates, if it is parallel to x-axis, their y coordinates will be same. Okay, if it is parallel to y-axis, its x-axis will be same. So, in this picture we see here, AB is a line parallel to x-axis. Okay, if you draw perpendicular lines from those points to x-axis, they are at P and Q. Okay, which are at the distance of, if you measure the difference between these two, they will be x2 minus x1. Correct? Because P point is x1 comma 0, Q is x2 comma 0. So difference between them, just we did before, difference in x-axis, that is x2 minus x1. Right? So if you see here, point A is x1 y1, point 2 is x2 y2, right? So y coordinate is no change. Okay, which means you can just find the difference of x coordinate, and then that is the distance. Okay, it is same with the y-axis also. Okay, same thing. If the line is parallel to y-axis, you will find only difference in the y coordinate. X coordinate will be same. So at that time, the distance is difference in y coordinate. Okay, same as before. So whether the 2 points are on the same axis or 2 points are parallel to axis, the method is almost same. Correct? So that's what is mentioned here. So just an example, you can check the example. 2 points 8 comma 3 and minus 4 comma 3. Here y coordinates are same. That means it is parallel to x-axis. So difference is 8 minus of minus 4, that is 12. 12 units is the distance between those 2 points. Okay. Now we can do this experiment, which is very easy. Here y coordinate is same. So difference of x coordinates, that is 3, is the distance between these 2 points. Okay. Second problem. Again, y coordinates are same. So difference between x coordinates is 4. Minus 4 minus of minus 8. That is minus 4 plus 8, which is 4. Okay. In third problem, x coordinates are same. So difference of y coordinates we have to check 8 minus 4, which is 4. So that's the distance. Here again x coordinates are same. So difference of y coordinates is minus 8 plus 12, that is 4. Okay. So this is how we find. Now let's do a another problem where one point is on x-axis, other point is on the y-axis. Okay. If you see A is on x-axis, which is 4 comma 0. Okay. B is on y-axis, which is 0 comma 3. Now how do you find the distance between those 2 points? So if you see these 2 points, which are on two different axes, correct? They form a right angle with the origin. Okay. So they form a right angle. If you see, this is a right angle, correct? If this is a right angle, I need a distance of uh, two sides, triangle side. Then hypotenuse I can calculate using Pythagoras theorem, right? So distance of OA is 4, OA is 4, OB is 3. So this is 4, base is 4, height is 3. Hypotenuse is square root of 4 square plus 3 square. Pythagoras theorem we apply basically, right? That is 5 is the hypotenuse. So distance between A and B is 5, 5 units. Okay. So this is how you calculate if the points are on the two different axes. Okay, you form a right angle and then calculate the distance using Pythagoras theorem. Okay, so similarly, there is some do this experiment. You can see very easily. Okay, A is 2 comma 0 and B is 0 comma 4. Okay, so yeah, with the A basically the length is 2, it will form with origin. Origin OA is basically 2, OB is, if O is origin, OB is 4. So AB is square root of 2 square plus 4 square. That is 16 plus 4 square root of 20 is the distance for this one. Okay. And here, if O is the origin, then OP is 5, OQ is 12. So square root of PQ is square root of 5 square plus 12 square. That is 144 plus 25. That is 169. That is square root of 169, which is 13. So 13 is the distance between these 2 points. Okay. Now similarly, find the distance between point O, that is origin, and A. Okay. Now this is a slightly different, but exactly the same problem. Let's say 7 comma 4 is here. Let's say. Okay. So if 7 comma 4 is here, origin is here, distance between these two, how do you calculate? You form it, you drop a perpendicular line to x-axis or y-axis, anything you can take. Okay. Then you again form a right angle triangle here, right? So height will be 7, base will be 4, correct? So hypotenuse is square root of 7 square plus 4 square. Okay, that is 49 plus 16. Okay, so square root of 65. Okay, that's the distance between origin and 1 comma 4. So this is exactly similar to above problems. Uh, uh, just it is forming a, we are calculating the distance from origin, not from any other point. Okay, we will go to the two general points also. Okay, now think about it. Ramu says distance of a point x1 comma y1 from the origin is square root of x1 square plus y1 square. Do you agree with Ramu? Why? Just now we calculated here. Okay. It forms a right angle with 7 comma 4 with origin. Okay. OA will be the hypotenuse. Okay. And 7 is the height, 4 will be the width. Okay. Two bases. So obviously it will be square root of x1 square plus y1 square. That's what we applied here also, right? So this is the general formula, distance from origin. Okay. Now, next, let's calculate the distance between any two points on the plane. This is the uh, general formula for distance between any two points. This is what we should remember. Uh, we can derive any formula from this. Okay? Any other distance formula. So this is also almost similar to the last one we learned x1 a b, a is x1 y1, b is x2 y2. So this is the line here. How can I find the distance between these 2 points? First thing I will do is I will drop two perpendicular lines from A and B onto one of the axis. I can even do it on y-axis also. I'm just choosing x-axis. Okay. So I drop a perpendicular line onto x-axis. From A it is AP. From B it is PQ. Okay. Now what is the PQ value? Okay. PQ is nothing but OQ minus OP, or difference between these two values, right? PQ is nothing but, just now we calculated, if 2 points are on the same axis, correct? Difference in one of the coordinates, which is not changing, is the distance. So for PQ, it is x2 minus x1. Similarly, for B and R, okay, the difference is y2 minus y1. Height is y2 minus y1. So we know that AR is, this is a right angle triangle, or a square or rectangle, square or a rectangle. So opposite sides will be same. So AR will be equal to PQ. So AR is also x2 minus x1. Similarly, BR will be y2 minus y1. So now what is the distance of this hypotenuse? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. We are just applying Pythagoras theorem, right? So this is the general formula for distance. Okay. General formula for distance between 2 points is square root of sum of squares of difference in x-axis and y-axis. Okay. Sum of squares of difference in x-axis and difference in y-axis. Okay. So now this is the distance formula which we should remember. Okay. So we can also write it as x1 minus x2 plus whole square plus y1 minus y2 whole square and whole square root. Okay. This is also true because anyway it is a square, so even if it is negative term, any negative term, it will go away, right? So it's just basically absolute value, square of absolute value. So both are correct. Okay. Now just a simple exercise is here before going into the do this section. Find the distance between 2 points 4 comma 3 and 8 comma 6. Now as given from x1 y1 x2 y2, these are the values. So distance equal to x2 minus x1 whole square, that is 8 minus 4 whole square plus y2 minus y1 whole square, 6 minus 3 whole square, which is square root of 4 square plus 3 square, or the answer is 5 units. Okay. So this is how you calculate the distance between 2 points. Now let's do the simple do this section and try this section here. Okay. Okay, do this section. Find the distance between the following pair of points. Okay, one is 7 comma 8 and minus 2 comma 3. Okay, just it needs the practice. Template is same. So we know this is the formula x2 minus square root of x2 minus x1 whole square plus y2 minus y1 whole square. So you substitute the values correctly. Minus 2 minus 7 whole square plus 3 minus 8 whole square, which is minus 9. So now minus 9 square is 81 plus 25, which is 106, and 10.29 decimal point. Okay. Similarly, minus 8 comma 6 and 2 comma 0. So answer you will get is 11.6. Okay. And 1 comma minus 3 and minus 4 comma 4. The distance between them is, you just to apply it properly. Substitute all the you get the answer 8.6. Now, Sweden calculate the distance between 5 comma 2 and minus 4 comma 1 to the nearest decimal as 9.5. Just to cross verify, yes, we did it. Minus 4 minus 5 whole square plus minus 1 minus 2 whole square, which is square root of 81 plus 9, which is square root of 90. Nearest value is 9.5. Yes. Now the distance between 4 comma 1 and minus 5 minus comma 2 also same. Okay. It is also same. So what do you observe? The points are different, but the value we got is same. Okay. If you plot them on the graph, actually both are parallel lines, and we are measuring the distance at exactly same point. Basically, if I cut off here, I get 2 points on two lines. If I cut off here, I get 2 points on two lines. The distance is same because both are parallel lines. So the next one. Let's do some more example, and this will give you a variety of problems with respect to distance calculation. Okay. Show that the points A 4, comma 2, B 7, comma 5, and C 9, comma 7 are 3 points lying on the same line. Okay. What we know is only distance formula as of now. So how do we basically find out that these three points are on the same line? Okay. Think about it. If 3 points are on the same line, okay, let's say A, B, C in that order, let's say, then AB, if I calculate the distance AB and BC, okay, then AC should be equal to AB plus BC, correct? If there is any difference in this, okay, if sum of two sides is not equal to third side, then it will form a triangle, correct? So let's check, okay? So it is what we know is only distance formula d equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now let's apply on A, B, B, C and AC. Okay. So if I see here, he has applied distance formula on A, B, B, C and CA. So what we got is 3 square root of 2 units, 1 AB. BC is 2 square root of 2. AC is 5 square root of 2. Okay. Now we can clearly see AB plus BC is equal to 3 square root of 2 plus 2 square root of 2, which is equal to 5 square root of 2. That is nothing but AC. Okay. So AB plus BC equal to AC. This is possible if and only if they are on the straight line. Right. So that means these 3 points are on the straight line. So this is a variety of a problem which we can solve using the distance equation itself. Okay. We can also solve this using slope equation. It will come in the later point of time. Okay. Let's see. And area of triangle also we can check. Okay. So if 3 points are on the same line or multiple points are on the same line, they are called collinear. Okay, just note down this. They may not tell always find out they are on the same line. They may call it collinear. Okay. Now, next example. Do the points 3 comma 2 minus 2 comma minus 3 and 2 comma 3 form a triangle? This is the question. Okay. Now, what is the rule for triangle we know? Okay. Sum of two sides should be greater than third side. Okay. Sum of two sides should be greater than third side. Only then it will form a triangle. Any other value you get, if it is less than or equal, it will not form a triangle. So let's find out distance of three sides of a triangle. I mean three lines length actually we'll find out. So if they are PQR points, let's say PQR, then we need to find PQ, QR and PR. So PQ is nothing but around square root of 50 or 7.07. QR is square root of 52 or approximately 7.21. PR is 1.41 units. Okay. Now, if you sum up three of them, two of them basically, PQ plus QR is obviously greater than PR. Okay. QR plus PR is greater than PQ, and PQ plus PR, that is 7.07 and 1.41 is greater than QR. So sum of any two sides is greater than the other side, third side basically. So that means it forms a triangle. Okay, and it will be scalene triangle mostly because all the sides are different. Okay, next. The next type of problem is show that the points, okay, these 4 points basically, are the vertices of a square. Okay, let us assume these are ABCD and ABCD of are the vertices of a square. Okay, so what are the rules of the square? All four sides will be same. So AB, BC, CA, and AD. Okay, CD and DA. Okay, these four sides will calculate. All will be same, but rhombus also has all four sides same. So the difference between rhombus and square is in square diameters also same. Okay, so let's calculate. You have to make total six calculations, six distance calculation. That is AB, BC, CD, and DA. And if I calculate, all four of them have square root of 34. Okay, square root of 34, square root of 34, and square root of 34. So all four sides are same. Now let's go to the diameter. Okay, AC. AC is again it is calculated square root of 68 and BD also square root of 68. Okay, so which means this with these 4 points, the whatever the polynomial formed, it's a square. Okay, next. Yeah, next type of problem what you can see is the figure shows arrangement of desks in a classroom. Madhuri, Meena, and Pallavi are seated at A, B, C points given here. A, B, C. Do you think they are seated in a line? Okay, this is nothing but collinear. Again, question of collinear. Okay, so you will find the distance between AB, BC, and AC. Right? So AB, BC, and AC. So AB is 3 square root of 2. BC is 2 square root of 2. AC is 5 square root of 2. So if I sum up AB plus BC, I'm getting AC, which means they are sitting in a line. Okay. Now, another type of problem is find the relation between x and y such that the point x comma y is equidistant from point 7 comma 1 and 3 comma 5. Okay. Let's say 7 comma 5 is here. Okay. You have the 7 comma 1 is at one place and 3 comma 5, and if it is equidistant, s comma y is equidistant, it will be a perpendicular bisector line equation, correct? So how do you find it? On that line, any point on that line will be equidistant from both of the points. So let's say the point is P, okay, x comma y is P, then AP should be equal to BP, okay, or AP square equal to BP square. We can remove the square root formula from distance calculation, okay. So since it is AP square, it is x minus 7 whole square plus y minus 1 whole square because A is 7 comma 1 and BP square is x comma y and 3 comma 5 distance, that is x minus 3 whole square plus y minus 5 whole square. If you expand them and remove the common terms, then we are left with basically minus 8x plus 8y equal to minus 16. Or if I divide both sides with minus 8, what I will get is x minus y equal to 2. Okay. So this is the equation, a relation of the x and y, okay, which is equidistant from these 2 points. Okay. So as I said, this is the perpendicular bisector of, if you call it AB, these points are AB, then it is a perpendicular bisector of AB. Okay, it will cut it like this. If AB is like this, it will cut it vertically. If it is horizontal, it will cut it vertically. Okay. Now, another type of question. Find a point on y-axis which is equidistant from both the points A 6, 5 and B minus 4, 3. Okay. Now it is very clear that he is telling it's a point on y-axis. Okay, which is very easy. Y-axis point is always 0, y form, right? So let's say the point is 0, y. and it is equidistant from P, A and B. That means PA equal to PB. So PA is equal to uh, 6 minus 6 square root of 6 square plus 5 minus y whole square. PB is equal to square root of minus 4 whole square plus 3 minus y whole square. Okay, so if I equate them basically, it will and simplify, what I will get is 4y equal to 36. This is what I will get from the simplification, or y is equal to 9. Okay, so the required point is 0 comma 9, because I assumed 0 comma y is the point on y axis. Okay, so required point is 0 comma 9. Now we can cross check the solution. AP and BP will get the same value. Okay, let's go to exercise now. Okay, find the distance between following pair of points. I will explain one of them, and the template will be same, and we just have to substitute the values properly and do the right mathematics, right addition, subtraction, okay, multiplication and division. That's it. Okay. So distance between 2 points x1, y1 and x2, y2 is square root of x2 minus x1 whole square plus y2 minus y1 whole square. This we know. Now there are 2 points. So x1, y1, x2, y2. So you have to just substitute the values. 4 minus 2 whole square plus 1 minus 3 whole square, which is square root of 4 plus 4, which is 2 root 2. Okay. So similarly, second one, okay, you will get the answer 4 root 2. And third one, same template you apply, you will get 25 root 2 as the answer. Okay. So when there are negative terms, be careful. Here it is 3 minus of minus 2, that is 3 plus 2. Okay. 3 minus of minus 2. Similarly, 2 minus of minus 3, which is 2 plus 3. Okay. So be careful when there are negative numbers in the coordinates. And a comma b and minus a minus b, this is a general term. Okay. So it's very simple. Minus a minus 2a whole square plus minus 2b whole square, that is 4a square plus 4b square, or 2 square root of a square plus b square. Okay. Okay. Let's see. Find the distance between the point 0 comma 0 and 36 comma 15. This is very simple. We just need, because it is 0 comma 0, we just need the square root of x square plus y square, which is this value, and 39 is the distance. Okay. Verify whether the points 1 comma 5, 2 comma 3 and minus 2 comma 1 are collinear or not. Okay. We know the collinear rule. If they are collinear, sum of the two distances should be equal to the third distance. Okay. So distance between 1 comma 5 and 2 comma 3 is calculated here as square root of 5. Okay. Then 2 comma 3 and minus 2 comma minus 1, it is 4 root 2. Okay. And the distance between 1 comma 5 and minus 2 comma minus 1 is 3 uh, square root of 5. Okay. So do they look, uh, summing up them will get the third side, any two of them? Okay. Yeah, definitely not. We will not get the same. Okay. So they are not collinear. Sorry, I missed the. Okay. Since sum of any two segments is not equal to the third segment, they are not collinear. Okay. Next. Check whether these 3 points are vertices of a isosceles triangle. Okay. What is the rule for isosceles triangle? All three sides, two sides should be same basically. Okay. Right. So this is the distance formula, and I'm finding the distance between 5 comma minus 2 and 6 comma 4, which is square root of 37. And distance between 5 minus 2 and 7 comma minus 2 is 2. And distance between 6 comma 4 and 7 comma minus 2 is again square root of 37. So if you see clearly, two sides are same, equal. Okay. And sum of these two is always, sum of any two sides is greater than the third side. So it forms a triangle and it's a isosceles triangle. Okay. Next. Show that the points form an equilateral triangle. Okay. Same thing, even the numbers are not given, your method is same. So this is the distance equation. Distance between a comma 0 and minus a comma 0 is nothing but 2a. Okay. It's a 2a whole square, right? So it will be 2a. And a comma 0 and 0 comma a square root of 3 is also 2a. Okay. Minus a comma 0 and 0 comma a square root of 3 also 2a. So three sides are same, equal, which means it forms a equilateral triangle. Okay. Next. Yeah. More variety of questions. Prove that the points taken in order are the correct corners of a parallelogram. Okay. Now parallelogram rule is opposite side should be same, right? So just find the distance of all 4 points in the order. Basically, if you call it A, B, C, D, then AB, BC, CD, and DA. So that's what I did here. And what I got is opposite sides are always same. Okay. So which means it forms a parallelogram. Okay. Next. Okay. Show that the points, these 4 points taken in order are the vertices of a rhombus. What is the rule for rhombus? All four sides should be same. That's all. Okay. So again, find the distance between 4 points in the same order. And I can see that all the distances are same. Length of all the sides are same, which is square root of 90. Okay. Or I can write it as 3 square root of 10. Okay. Whatever. So it forms a rhombus. Next. And also you have to find the area of the, find its area. Okay. This is the second part of the question here. So area of rhombus is equal to half of product of diagonals, if you know it, right? D1 into D2 by 2, right? Half of product of diagonals. So we need to find the diagonal. So take the alternate point minus 4 comma minus 7 and 8 comma 5 distance, minus 1 comma 2 and 5 comma minus 4. So diagonal 1, 12 square root of 2, diagonal 2 is 6 square root of 2. So area of rhombus equal to product of these two divided by 2, which is 72 square unit. Okay, next. Name the type of quadrilateral formed, if any, by the following points and give the reasons for your answer. Okay, we need to, they'll give the points and we need to find out what kind of quadrilateral it forms. Okay, these are the 4 points. Uh, it's the same basically. I'll find the distance of all four sides. And if I see here, all four are equal. Okay, which means either it is the rhombus or a square. Correct? Let us check the diagonals. Now, the diagonals also same, which means it's a square. These are the coordinates of a square. Okay. Next. Okay. Another 4 points are given. Uh, just finding the distance between these two. If I see opposite sides are same. Okay. If opposite sides are same, either it is a parallelogram or a rectangle. Correct. Now let's find the diagonal. Diagonals are different, which means it's a parallelogram. Right. Okay. So we have just one equation and we are just finding so many variety of problems to solve with this. Okay. This is the beauty of coordinate geometry or maybe further it will go into geometry. Okay. Another 4 points are given. So the distance I found is again alternate sides are same. Okay. And I'm finding the diagonals. So diagonals are different, which means again it is a parallelogram. Okay. Next. Find a point on x-axis which is equidistant from 2 comma minus 5 and minus 2 comma 9. Okay. So let the point on x-axis be a comma 0. Okay, which is equidistant from these 2 points. Okay. So distance between a comma 0 and 2 comma minus 5 is equal to distance between a comma 0 and minus 2 comma 9. Okay. So this is the, if I substitute those values in the equation, this is what it is. and I can do square root on both sides. I'll get a square minus 4a plus 4 plus 25 equal to a square plus 4a plus 4 plus 81. If I simplify it, what I will get is a is equal to minus 7. Okay. So minus 7 comma 0 is equidistant from these 2 points. Okay. Next, which is on the x-axis also. If the distance between x comma 7 and 1 comma 15 is 10, find the value of x. Okay. So this is another kind of problem. Distance is given and the point is one of the coordinate is not given. Okay. So distance equation we know square root of x minus 1 whole square plus 7 minus 15 whole square equal to 10. Or if I simplify it, I'll get a quadratic equation x square minus 2x minus 25 equal to 0. Okay. If I factorize and check the roots, I'll get x equal to 7 or minus 5. Okay, there are two values. What is the meaning of this one? Okay, 7 or minus 5. Okay, so from this point, okay, if the y coordinate is same, right? Either it will form a 7 comma 7 or minus 5 comma 7. These are the 2 points. That means y coordinate is same, which means it's parallel to x-axis. Okay, if I put these 2 points, 7 comma 7 and minus 5 comma 7, it is parallel to x-axis, correct? So these 2 points are on the two on the same x-axis parallel line. These are the 2 points which are equidistant from this point. Okay, next, find the values of y for which the distance between the points is 10 units. Again, similar problem. So put the template distance equation. Okay, and you will get y square plus 6y minus 27 equal to 0. If I simplify, I'll get y equal to minus 9 or 3. Okay, this is parallel to y-axis. Okay, so sorry, this is the value of the y. Okay, and if the x coordinates are same, basically, which means x coordinates are same, so it is parallel to y-axis. So you will get 2 points on the same line. Okay, parallel same line, you will get 2 points which are equidistant from uh, 2 comma minus 3. Okay, next. Find the radius of the circle whose center is 3 comma 2 and passes through minus 5 comma 6. Okay, center is here. Okay, and this is the point on the circumference of the circle. So radius is obviously distance between these two, which is 4 square root of 5. Next. Can you draw a triangle with vertices 1 comma 5, 5 comma 8 and 13 comma 14? Okay. Now we know the triangle rule. Sum of two sides should be greater than the third side. So first find out the distance between these two with using these 3 points. Okay, I get 5, 10 and 15. 5, 10 and 15. If I see it clearly, they are collinear because 5 plus 10 equal to 15, which means they are collinear. Not you cannot form a triangle with this. Okay. Next, find a relation between x and y such that the point x comma y is equidistant from point minus 2 comma 8 and minus 3 comma 5. Okay, this is similar to the example given. So distance between minus 2 comma 8 and x comma y is equal to distance between minus 3 comma 5 and x comma y. So this is the I substitute the values in the equation. Okay, and then simplified, what I will get is 2x minus 6y plus 34 equal to 0. Okay, so this is the perpendicular bisector equation, which is equidistant from 2 points always. Okay, every point on the perpendicular bisector will be equidistant from the 2 points. Next, in a classroom, four friends are seated at the points A, B, C, D shown here. Okay, okay. Jerina and Funny walk into the class, and after observing a few minutes, Jerina asks Funny, "Don't you notice that ABCD is a square?" Okay. Funny disagrees. Using distance formula, decide who is correct and why. Okay. So first thing is let's put the coordinates for this one. A is nothing but 3 comma 4. Okay. This is 6 comma 1. D is okay. B is 6 comma 7. Okay. And C is 9 comma 4. Okay. So A, B, C, D. These are the points. Now we just need to find the distances of four of them. Okay. All four distances are same. That is 3 square root of 2. So we need to find the now um, diagonal distance. Actually, you can count the diagonal distance very easily. 1, 2, 3, 4, 5, 6. Okay, 6 units. 1, 2, 3, 4, 5, 6. Both diagonals are same. Okay, now using our formula also, I'm getting 6 and 6, which I can clearly see here, 6 and 6. That means diagonals are same, four sides are same, so it's a square. So who is correct? Okay, very nice. Next. Find a relation between x and y such that x comma y is equidistant from 7 comma 1, 3 comma 5. So same, we have done this similar problem. So simplify it. The equation is 20x plus 8y plus 16 equal to 0. We can further simplify if you want. Okay, now let's go to section formula. Section formula. Section formula is all about dividing a line in the given ratio. Okay, so a line segment is formed by how many points? You need minimum is 2 points, right? So once you have the 2 points, you can draw a line segment and you have to find a point on that line which can divide the given line segment in m is to n ratio. Okay, so this is what the section formula, and with this we can create plenty of example problems actually, which we can solve using only this idea. Okay, so let's take an example. A person is traveling 36 kilometers to the east. Okay, you can see right from A to E, 36 kilometers, and 15 kilometers to the north. Okay, 15 kilometers to the north, that is to the B. Now we know that the line segment is AB now, correct? Shortest distance is AB. Now a telephone company want to install a tower at a point on AB, okay, which divide this line in 1 is to 2 ratio. Okay, so basically a story is created, but the summary is you have a line segment AB. You need to find a point P which can divide this line in 1 is to 2 ratio. Okay, so how do we do this? It is easy. We have to use the similar triangle method. Okay, similar triangles we will use, and then we can get the values of x and y. Okay, how he has done is this is 36 kilometers because he went 36 kilometers east and 15 kilometers west. So this is 15 kilometers. Now P is here. I will call P coordinates as x comma y. So obviously this OD is x and DP is y. Correct? Since this is a rectangle, CE also y, okay, and BC will be 15 minus 5, correct? Okay. Now, on the x side, basically, this is x, so DE will be 36 minus x. So this is a rectangle again, so PC also 36 minus x. Now you look at these two triangles carefully, ODP and PCB. Okay, angle O and angle P is same. Why? Why both are same? These two are parallel lines. Okay, PD and BE are parallel lines. So this is a transversal. So it will make same angle at O, that is PAD as well as BPC will be same. Okay, these two are same. And similarly, these two angles also same. Okay. angle BPC and angle, BPC, that's angle here, and OPD, this angle also same, okay? And anyway, angle PDO and angle BCP are 90 degrees, okay? So angle here and angle, two angles are same, so third angle also will be same, right? So these two triangles are similar triangles, okay? In the order, same order, ODP and PCB. Okay, once you know this, you can use the ratios of the sides basically, okay, to get the values of x and y. Let's see how it is done. OD by PC equal to OP by PB, which is 1 by 2. Okay, we know the OP by PB is 1 by 2 because we are dividing it into 1:2 ratios. So this is 1 by 2. Okay, so OD by PC also will be 1 by 2 ratio, x by 36 minus x, correct? So x by 36 minus x equal to 1 by 2. And similarly on the y side also, y by 15 minus y is 1 by 2. If you simplify, you will get x equal to 12 and y equal to 5. Okay. So with this, we got the value of x comma y, which is 12 comma 5. Okay. These are the coordinates where point basically which will divide this AB into 1:2 ratio. Okay. So this is called section formula. Now we need to generalize it, right? Here we have taken A at origin. Okay. What if it is not origin and if it is some other point? Okay. Because origin is 0 comma 0, then we calculated the coordinates of B, that is 36 comma 15. But what if it is not at the origin? Okay. So that is the general method. But you will apply exactly same principle and prove that AQP triangle is similar to PCB. AQP is similar to PCB. Okay, and the ratios are M1 and M2. Okay, the points are x1, y1 and x2, y2. So x comma y will be given by, if you do this similar triangles and then ratios of the sides, you will get exactly the value which is derived. X is equal to M1 x2 plus M2 x1. Okay, divided by M1 M2. Okay, and M1 y2 plus M2 y1 divided by M1 y2. Okay, this is what you will get. Okay, and just not to get confused, the M1 M2 are written in the same order as M1 and M2, correct? Only thing is difference is instead of x1 y1 x1 x2, we are writing x2 x1. Okay, so just remember this. Similarly here, y2 y1 instead of y1 y2, not in the same order, reverse order. Okay, of x2 x1 and y2 y1. This is the will run. So this is the uh, section formula. Uh, okay, a point dividing two points into the given ratios. M1 is to M2. Okay. Now, if the ratio is k is to 1, obviously you will replace M1 and M2 with k and 1. This is what you will get. Okay. And just a special case is if it is a midpoint. Okay. Midpoint always divides the line in 1:1 ratio, right? So, M1, M2 you will replace with 1. What you will get is x1 plus x2 by 2 and y1 plus y2 by 2. Okay, this is the midpoint formula. Okay, you can directly use this, less complicated, so you can remember easily, right? So let's see some examples of this section formula where we can be used. The straightforward question is, you are given 2 points basically and you have to divide in 3:1 ratio. Okay, you will simply apply the formula, right? Here m1 is 3, m2 is 1. m1 is 3, m2 is 1. 3, 1. Okay, x1, x2. So first is x2 will come, right? Reverse order. x2, x1. Okay. Similarly on the y side. So you will get 7 comma 3 as the required point. Okay. Let's see more types of examples. Find the midpoint of the line segment joining these points. 2 points. Midpoint equation is x1 plus x2 by 2, comma y1 plus y2 by 2. Right. So you just apply 3 plus minus 1, that is 3 minus 1 by 2, that is 2 by 1, 2 by 2, which is 1. Okay. And 0 plus 4 is 4. 4 by 2 is 2. So 1 comma 2 is the answer. Okay. Let's do this section now. Okay. Find the point which divides the line segment joining the points in 2:3 ratio. Okay. Okay, x comma with the required point. So this is the template you will follow, right? And this is the formula. First you will write the formula and then substitute the values. Okay. M1 is 2:3. So M1 is 2, M2 is 2, 3, and X1 is 3, X2 is 8. So they will be in reverse order like this. Okay. Similarly, Y2, Y1. Okay. Now if you substitute, what the value you will get is 5 comma 7. Next, find the midpoint of the line segment joining these two lines. Let's do it here. It's 2 plus 12, 14 by 2, which is 7. 7 minus 7, 0, 0 by 2, 0. So 7 comma 0 is the answer, right? So this is how we should do these section formula problems. Now let's go to the trisectional point of line segment. Okay. Previously we have done only we we found the coordinates of only one point which divides the line in m is to m1 is to m2 or m is to n ratio, right? Given ratio. Now we need to find 2 points which will divide the line in the given ratios. Okay. More or less in this one, most of the people will ask equal segments, right? Okay. So trisection. So you need to make the line into three parts. Previously we made two parts, line into two parts. Okay. Now we need to make the line in three parts. Okay. A point which divides a line segment into three equal parts are said to be trisectional points. Okay. Let's do it by example. It's very easy. We just apply the section formula only here. Find the coordinates of the point of trisection of the line segment joining points A 2 comma minus 2 and minus 7 comma 4. Okay, if it is A and B are here, you need to find 2 points P and Q which will divide this equally. Okay. Now if you look at P divides AB in 1 is to 2 ratio. Correct? This is PB is 2 times, AP is 1 time, 1x, 2x. Similarly, Q divides AB in 2 is to 1 ratio, right? This is 2x, this is 1x. So we just apply the section formula two times and then we'll get the values of P and Q. Okay. P divides 1 is to 2 ratio. So here it is 1 is to 1 is to 2 ratio. Okay. And we get the value of minus 1 comma 0 P. And Q divides in 2 is to 1 ratio. So apply 2 is to 1 ratio here. You get the values of minus 4 comma 2. Okay. Method is same. Exactly section formula is what you will apply. Only thing is you need to be careful. What is the ratios of ratios in which individual point is dividing the whole line? Okay. Okay. So obviously we understood that PQ divides AB in the ratio of 1 is to 2 and 2 is to 1. Okay. Now let's do this section. Okay. Find the trisectional points of the line segment joining 2 comma 6 and minus 4 comma 8. Okay. Let's PQ are the two trisection points. Okay. Same formula will apply. First, P divides the line segment in 1 is to 2 ratio. So you apply the values 1 is to 2 ratio. M1 is 1, M2 is 2. 1 plus 2, right? 1, 2, 1 plus 2. And these x2 and x1 will be reversed. So x2, x1. So x2, x1, y2, y1. Okay. If you apply, you will get 0, comma 20 by 3 as the P coordinates. Similarly, Q divides the line in 2 is to 1 ratio and you apply the same formula, section formula, you will get minus 2 comma 22 by 3. Okay. So these two are the trisectional points. Divide the line segment in three equal parts or trisection point. Okay. Next, same problem, exactly same template you will follow and you will find out P and Q, which is exactly minus 4 comma 6 and minus 5 comma minus 7. Okay. These are the points which will divide the line segment into three equal parts. Okay. Now, let's check this, try this section. Okay. Let A, B, C are vertices of a triangle ABC. Okay, ABC are vertices of a triangle ABC. Three coordinates are given. AD is the median of BC. Okay, it's given AD is median of BC. Find the coordinates of the point D. Okay, so these are the 3 points minus 4 comma 2, 6 comma 5, and 1 comma 4 vertices of ABC. AD is the median of BC. Find the coordinates of D. Okay, so AD is median. That means D is the midpoint of BC. Okay, D is the midpoint of BC. Correct. So midpoint formula, use the midpoint formula and find out the coordinates of D, which is BC are 6 plus 1 by 2, 7 by 2, 5 plus 4, 9 by 2. Okay, so these are the coordinates of D. Now, find the coordinates of point P on AD such that AP is to PD is 2 is to 1. Okay, so A and D I have, and M1 is to M2 is 2 is to 1. So I apply the formula, I get the values as 11 by 3 comma 11 by 3. Okay, now next, find the points Q and R which divides the median BE and median CF respectively in the ratio of 2 is to 1. Okay, he did not give exactly, but which one is E is B is one median and CF is other median. Okay, if you calculate same way as before, you get exactly same point because all medians in a triangle intersect at the same point, right? So you will get, actually, if you calculate, you will get the exactly same coordinates as this one. 11 by 3 and 11 by 3 is what you will get for the rest of the coordinates also. PQR will be same point basically. Okay, this we can easily do it. Exactly same procedure you have to follow. You need to find F first, which is midpoint of AB, and then F and C dividing in CF divided in 2 is to 1 ratio. Okay, and similarly BE divided in 2 is to 1 ratio. Okay, next, centroid of the triangle. Okay, what is centroid of the triangle? Okay, centroid of a triangle is the point of concurrency of its median. Okay, so just now above example what we have done basically exactly same thing here. Okay, so if you substitute these values same way as before, instead of the real numbers, okay, instead of the real numbers, you put x1 y1, x2 y2, x3 y3. You first find the midpoint D of these 2 points. Okay, x2 plus x3 by 2 and y2 plus y3 by 2, and then find out the 2 is to 1 ratio of AD. Okay, then what you will get is basically x1 meet the centroid basically, right? G is called centroid, is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Okay, so let's check, just cross check once. Okay, here what we got. Okay, so these are the 3 points. If median, these are the median centroid coordinates. So 4 plus 6, 10, 10 plus 1, 11, 11 by 3, correct? 2 plus 5, 7, 7 plus 4, 11, 11 by 3. Okay? So this is what we got here, right? So this is the formula for the centroid. Okay, remember it, it's very easy. Okay, so it's a simple example is here. All three coordinates of the triangle are given. You just need to find the centroid using this formula. Okay, that's very easy. Okay, and yeah, of course, here also it's very easy. Minus 4, centroid of these 3 points, given points is minus 4 plus 2, minus 2 plus 2, right? 0, 0 by 3 is 0. 6 minus 2, which is 4. 4 plus 5, 9. 9 by 3 is 3. So 0 comma 3 is the centroid of these three numbers. Okay, now let's see some example questions. In what ratio does the point minus 4 comma 6 divide the line segment joining the points these two A and B? Okay, so this is reverse. Instead of giving the ratio, they gave the x comma y, which is dividing A and B, and we need to find what ratio it is going to divide. Okay, so we will just substitute the same values. M1, M2, we don't know. We need to find out. So we basically get two equations. Okay, The first coordinate, x coordinate equal to -4, y coordinate equal to 6. If you substitute this, you will get two equations. You simplify them. Okay. If you simplify them, you will get m1 by m2 as some ratio. Okay. In this case, it is 2 by 7. Okay. So this is one kind of problem which you will get. Okay. If you verify the other one, you will get same way. Okay. And also you can cross check once you know that it is 2:7 ratio, you can cross check. Okay. Okay. Let's do the think and discuss session. There is a line segment 6 comma 9 and -6 comma -9. Okay. What ratio does the origin divide AB and what is it called for? Okay. So if you see it, this is x comma y and -6 comma -y. So if I add them, average of them basically x1 plus x2 by 2, that is 6 minus 6 by 2 is 0, 9 minus 9 by 2 is 0. So origin is the midpoint of AB. Okay. Now 2 comma 3 will divide. If you just apply the ratio and find out, 2 comma 3 will divide in 1:2 ratio. -2 comma -3 will divide in 2:1 ratio. Okay. If you want to quickly check 6 and -6, right? So 2:3 ratio to 2 into -6 plus 3 into 6. So you'll get 6. 6 by 3 is 2. Okay. So this will divide into uh, 1:2 ratio. This will divide in 1:2 ratio. This will divide 2:1 ratio. So P and Q are basically trisection points. Okay. Now let's see more examples. Find the ratio in which y-axis divides the line segment joining the points 5 comma -6 and -1 comma -4. Also find the point of intersection. Okay. So let that ratio be k:1. Okay. Then from section formula, we'll apply this k:1, right? So this is the formula. So here x2 is -1, x1 is 5. Similarly, y2 is -4, y1 is -6. If I apply all this is the equation I get. And we are trying to assign this to we are trying to find out a point on y-axis, right? Because it y-axis is dividing this line segment. On y-axis, x is 0, right? So simply you take the x coordinate, that is minus k plus 5 by k plus 1 equal to 0. If you simplify, what you will get is k equal to 5. Okay. So k:1 is 5:1. So y-axis divides these 2 points in 5:1 ratio. Okay. You can cross check by substituting the value. Okay. Then you will know. Okay. You will also know the point of intersection. Okay. Next. Show that the points 7 comma 3, 6 comma 1, 8 comma 2 and 9 comma 4 taken in that order are vertices of a parallelogram. Okay. So previously we did some examples where we found if the given vertices are given points are vertices of a parallelogram or not by calculating the distance. Okay. In a parallelogram, opposite uh, sides are equal, right? AB equal to CD, AD equal to BC. So this is how we calculated last time. But there is another way, which is if you see, if you take any parallelogram, the two diagonals actually bisect each other. Okay, that means midpoint of two diagonals is same. Okay, midpoint of two diagonals is same. So what is the midpoint formula? This is very easy compared to distance formula, which is square root and you have sum of squares. Instead of that, it is just x1 plus x2 by 2, y1 plus y2 by 2. You apply for diagonals. Okay. So if you see here, 7 plus 8, 15 by 2. Okay. 1 point. 3 plus 2, 5 by 2 with the y coordinate. Similarly, 9 plus 6, 15 by 2. 4 plus 1, 5 by 2. Okay. So both the diagonals midpoint is same, which means the given coordinates are basically of parallelogram. Okay. It can be triangle, it can be rectangle, it can be square, it can be rhombus, but whether it is a rhombus, whether it is a square or rectangle, we need to find out few more things, right? Distance of diagonals is same for rectangle. All sides should be equal for a rhombus, correct? And all sides and the diagonals and are same, and the diagonals also equal for a square. But to tell, if you don't calculate all those things, you can tell the given diagram is a parallelogram, right? So this is enough to confirm that it's a parallelogram. If it is rhombus, then we need to do more. Okay, if it is a square, you need to do more. Okay, so this is another way of finding if the given points are parallelogram vertices or not. Now, next. 4 points are given, and x coordinate of point D is not known. That is why it is P. Are the vertices of a parallelogram taken in that order? Find the P. Same thing. You will find. You will do exactly same. Midpoints of the diagonal you take, and then you will get one equation. You will get the value of P if you simplify it. P equal to 7 in this case, in this example. Okay. Yeah. Let's do the exercise button. Okay. Find the point which divides the line segment joining points -1 comma 7 and 4 comma -3 in the 2:3 ratio. The template is same. Okay. First problem I will explain. The rest all will be exactly the same. Okay. So uh, the point which divides in m1 is to m2 ratio is m1x2 plus m2x1 divided by m1 plus m2, comma m1y2 plus m2y1 divided by m1 plus m2. You just substitute the values carefully. It's a 2:3 ratio. So m1 is 2, m2 is 3, 2, 3. Okay, and this is x2, this is x1. So if you substitute all the values, you will get the answer 1 comma 3. Similarly, the trisection points of line joining is given 2 points. You will first find the p coordinates which will divide the line in 1:2 ratio, 1:2 ratio, and you will find the q coordinates which will divide the line in 2:1 ratio. Okay, so these are the points. Okay, next. Find the ratio in which the line segment joining these 2 points is divided by this. Okay, so now in this case, we need to find the ratios. Okay, so let's assume it is dividing in k:1 ratio. K is a real number. And if you substitute that, what you will get is basically you take one of the equation. Okay, 6k minus 3 divided by k plus 1 equal to, okay, 6k minus 3 divided by k plus 1. Okay, sorry, this was is here, which is equal to -1, right? It is equal to -1, x coordinate that is. So 6k minus 3 divided by k plus 1 equal to -1, or if I simplify, what I will get is 7k equal to 2, or k equal to 2 by 7. Okay, this is, I think, somehow it came, it should be, this is wrong here. Okay, yeah. K is 2 by 7, so the ratio is 2:7. Okay, don't know, I did a lot of mistakes. Okay, the ratio is 2:7. Okay, the point -1 comma 6 divides the line segment in 2:7 ratio. Now, next one. Okay, so 4 points are given. One of the point you don't know the y coordinate, and one of the point you don't know the x coordinates. These are the vertices of a parallelogram taken in that order. Find x comma y. So vertices, we know we need to take the midpoint of the diagonals. So 1 comma 2 and x comma 6 midpoint. So 1 plus x by 2 and 2 plus 6 by 2. And 4 comma y and 3 comma 5 midpoints. That is 4 plus 3 by 2 and y plus 5 divided by 2. If I equate the x terms and y terms, I will get the x and y values as 6 and 3. Okay, next. Find the point A where AB is the diameter of a circle whose center is at this point and B is 1 comma 4. Okay, AB is diameter of a circle. Okay, so basically we need to find exactly other end of the B. Okay, right, and this is the center. So we know that center divides center divides the diameter in two equal parts, that is 1:1 ratio. Okay, that means 2 comma minus 3 divides x comma y and 1 comma 4 in 1:1 ratio. So from section formula, if I apply midpoint theorem, 1 plus x by 2 and 4 plus y by 2, which is equal to 2 comma minus 3. If I equate, I'll get the x and y values as 3 and minus 10. So a is 3 comma minus 10. Okay, AB are given. Find P on AB such that AP equal to 3 by 7 AB. Okay. So AB is nothing but AP plus PB. Okay. AP plus PB is AB. So AP equal to 3 by 7 AB, which is given. So if I substitute that, what I will get is AP by AB is 3 by 4. That means P divides AB in 3:4 ratio. Okay. So I'll just apply the section formula for 3:4 ratio and then I'll get the values here. Okay. So you can actually draw a line how this APB is basically AB and you have a P in between, right? So AP plus PB is AB. Okay. So that's how we will get to this one. This is AP by uh, AP by PB. This is sorry. Okay. AP by PB. Next. Find the points which divide the line segment into four equal parts. This is just extension of your trisection points. Okay. So we know that if you need four equal parts, basically the first one will divide in 3:1 ratio. Okay, R will divide. Basically, P is the first one, Q is second one, R is third one, but just I wrote in reverse. R divides in 3:1 ratio, Q divides in 2:2 ratio, and P divides in 1:3 ratio. Okay, now you know the ratios. You apply the section formula. You have the points. You will get the values of P, Q, and R. Okay. Find the point in which find the point which divides the line segment A and B into four equal parts. Exactly same problem. So just apply the same thing here, same template exactly. You'll get the values. Okay. Next, find the point which divides the line segment joining A plus B, comma A minus B and A minus B, comma A plus B into 3:2 ratio. Okay. So I'm just applying the section formula here and simplifying it. So that's all for all these questions. You have to do exactly same. Okay, these four are exactly same. Ninth, uh, and these four questions basically. Okay, and here it is centroid. So centroid formula I am applying x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. Okay, 3 points are given. Okay, I think there is some mistake. I think this is, I don't know why this 10 has come here. Okay, these three are 10th questions basically. Okay, 1, 2, 3. Okay, these are the 3 points exactly same. Centroid you have to find out. Next. Find a point A, x comma y when C divides AB in the ratio 2:3. Points B and C are given as minus 5 comma 8 and 3 comma 6. Okay. So C is dividing AB in 2:3 ratio, right? BC are there. Section formula and the A is x comma y. So 3 comma 6 equal to section formula you will apply. You will get x coordinate and y coordinate separately and you can solve for x and y. Okay. Similarly, the line segment AB meets coordinate axis in points A and B. If point 3 comma 6 divides AB in the ratio 2:3, then find the points A and B. Okay. What are the points A and B? A is on x-axis, B is on y-axis. Okay. So AB are on the coordinate axis. So A is equal to x comma 0 B is equal to 0 comma y. Okay. Now we just need to apply the section formula. That's it. Okay. So 3 comma 6 equal to, yeah, this formula. What you will get is x equal to 5 and y equal to 15. Okay. Next. So A and B are here. Okay. Now let's go to the area of triangle section. Now let us learn how to calculate the area of the triangle in a coordinate plane. Okay. So if you see the diagram, the coordinates are given for A and B. A is 0 comma 4 and B is 6 comma 0. Okay. They form a right angle triangle with origin, that is 0 comma 0. Okay. Now what is the area of the triangle? Yeah, this is to begin to calculate the area of triangle. Okay, we'll go step by step and calculate for any triangle, not only just right angle triangle, not only the triangle where one of the vertices is origin. Okay, we will go step by step. So in this case, it is very easy. We know that height of this right angle triangle is 4 units because it is 0 comma 4, and uh, base of the right angle triangle is 6 units because 6 comma 0 is the other point. So area of the triangle is half into base into height, that is 12 square units is what you will get. Okay. So this is a simple way of calculating the area of a right angle triangle where uh, one of the vertices is origin basically, or especially the vertices with right angle is origin. Okay. So yeah, this is same. We just discussed about it. Okay. Now let's see different combinations here. Okay. So yeah, if AB are like this and C is at origin, okay, right angle at B and C is origin and A is another point, and this is a right angle triangle. So again you will calculate base and height. So whatever is the y coordinate here, that is the height. X coordinate here is the base. So half into base into height you can calculate. Same here. Okay. And yeah, here also you have to subtract for base. You have to subtract x coordinates of A and B. That is x2 minus x1 you will do here. Y2 minus y1 you will get the height. Okay. So half into x2 minus x1 into y2 minus y1. Same thing here. Okay. So these are the different right angle triangles. Still we can calculate them very easily. We don't need a big formula for calculating these areas. Now let's see more general general triangle. Okay, any general scalene triangle looks like this. Okay, in the coordinate plane, and the vertices are x1, y1, x2, y2, and x3, y3. Now, how do you calculate the area of this triangle? Okay, let's calculate the area of a triangle, a scalene triangle. Okay, and this will be the general formula for area of triangle. Okay, let's say there is a triangle like this in the coordinate plane, and the vertices are at x1, y1, x2, y2, and x3, y3. Okay, now how to calculate this area of this triangle, scalene triangle? It is not a right angle triangle, it is just a any shape. Okay, so how we can do is you have two ways. Either you can draw the perpendiculars onto y-axis or x-axis. In this case, we have drawn perpendiculars to the x-axis. Okay, you draw perpendicular from ABC onto x-axis. So from B it is Q, from A it is P, from C it is R. Okay. Now if you see, observe carefully. If you observe carefully, there is A B Q P is a trapezium. Correct. A B Q P is a trapezium. Also A P R C also a trapezium. Okay. Correct. And also BQRC. This is also a trapezium. Okay. So if I sum up first two trapeziums, that is BQ or ABQP plus area of APRC, then what is the extra thing coming? This part, right? and I subtract this part. This is also area of a trapezium, which is BQRC. Okay, so that is what is mentioned here. Okay, area of triangle ABC equal to area of trapezium ABQP. Okay, once again I'm showing here ABQP plus area of trapezium APRC. Okay, minus area of trapezium BQRC. Okay, I'm cutting off this part basically. So I will get only the area of ABC. Correct? So area of trapezium we know, distance between parallel lines and sum of half into sum of parallel lines and distance in multiplied by distance between the parallel lines. Okay. So if you see here for the first trapezium, I'll explain here. Uh, BQ is, we know the Y2, that is nothing but Y2. Correct? AP is nothing but Y1. Okay. So Y2 plus Y1. Okay. Multiplied by QP. QP is nothing but X1 minus X2. X1 minus X2 is QP, right? So, and yeah, distance between them, sum of parallel lines. That's all we got. Okay. So for each trapezium, you find out what is the sum of the parallel lines and the distance between them, and then substitute them. You simplify. Okay, this is the first one which we calculated. Okay, half into y2 plus y1 times x1 minus x2. Okay, and so on for the three of the trapeziums. And the third one is a negative, basically minus, right? You are subtracting. If you simplify it, what you will get is area of triangle ABC equal to half into absolute value of, because the area cannot be negative, that's why we are taking absolute value. Half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay. So this is the area of the triangle in the general form. Okay, where three vertices are given and it's not a right angle triangle, it's just a scalene triangle. Okay, let's see some examples with this. Find the area of triangle whose vertices are three of them are given here. We just need to substitute and substitute them carefully. Okay, first is x1 is 1, y2 minus y3 is 6 minus 6 minus of minus 5, that is 6 plus 5. Okay, then plus x2, so here it is plus into minus 4. Okay, into y3 minus y1, that is minus 5 minus of minus 1, that is plus 1, minus 5 plus 1. Okay, then third one is x3 minus 3 into, okay, minus 1 minus of minus 1 minus 6. Okay, if you simplify, what you will get is 24 units as the area, 24 square units as the area, this triangle. Okay, so similar many such examples we can do. Find the area of triangle formed by the points given. Again, it's same, you have to just substitute them carefully. Can go through the example here. You will get the area as 2 square units. Okay. Now, yeah, there is a do this section. Okay. Okay. Find the area of the triangle whose vertices are, these are the 3 points given. So if you are doing this problem, you just need to have a fixed template like this. Area of triangle equal to half into x1 minus x1 into y2 minus y1 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Okay. Once you have this formula, then it is x1 y1, x2 y2, x3 y3. You just substitute the values carefully, and the area you will get is 32. Okay. And the second problem is again three vertices are given. You have to just follow the same template. The area you will get is 15 square units. Okay. Now more examples we'll see here. Okay. Now how to find the area of the quadrilateral. Okay, where ABCD, the vertices of the quadrilateral are given in the same order. Okay, how to find now area of this quadrilateral? Okay, so this is simple. You draw one of the diagonal. Okay, and then the quadrilateral is broken into two triangles, right? Area of quadrilateral is equal to sum of both the triangles. So that's what we are doing. We are calculating the area of triangle ABD and triangle BCD and then sum them up basically. Okay, so we use the same triangle formula and we can calculate the area of quadrilateral also. Okay, in this case it is 19 square units. You have to calculate area of triangle ABD plus triangle BCD and sum them up. Add them, you will get the area of quadrilateral. Okay, so 19 plus 53, that is totally 72 square units. This is the area of the quadrilateral. Okay, now we have a section one. Try this section. One example is given. Problem. Okay, find the area of the square formed by these vertices. Okay, area of square is actually easy. You can easily do looking at the coordinates, but you just apply the same principle. So area of square ABCD is the area of ABD plus BCD or twice the area of ABD, because we know that if it is a square, okay, diagonal basically bisects the areas into two equal parts, correct? So you apply that logic. Okay, for every quadrilateral, you don't need to do two calculations. Okay, once you know that it is either rectangle or a square, you can actually do this way also. Okay, so anyway, you can apply this triangle area formula, and area of triangle ABD is 4 square units. So square area is double, basically double that of this one. Just for showing you that other area also same, other triangle area also same, I just calculated here triangle BCD area, which is also 4. Okay, so area of the square is 8 square units. Okay, now next. So there is a think and discuss section here. Let's go here. Find the area of the triangle formed with the following points. Okay, this is a simple, straightforward equation. We substitute all the values carefully. So observation is we got the area formed by these 3 points is 0. What is the meaning of this? Okay, the meaning is basically three points are on the same line. That means they are collinear. Okay, just in the beginning of the session when we are learning distances, we have way we learnt one way to find if the three numbers are collinear or not. How did we find it? We basically collected the distance between the 3 points, okay, and then see if sum of the two distances is equal to the third side, correct? And here another way of finding if the 3 points are collinear, that is if area of the triangle is 0, that means those 3 points are on the same line, correct? Only then area of the triangle will be 0. So this is another way, correct? This is another way of finding if the 3 points are collinear. This is comparatively easy because distance calculation involves square root and squares, correct? And you have to do three calculations there. So compared to that, this is relatively very easy. And once you know the slope equation, you can actually do using slope also. This that is also easier one, but you can choose whichever is you feel is easy. You can use it. Okay. Now let's learn the collinearity. Okay. Okay. We learned collinearity before using the distances. Okay. If the points lie on the same line, they are called collinear points. Okay. Right. And also, if the area of the triangle formed by the 3 points is 0, then also they are collinear. Correct. So let's do some examples. If these 3 points are in a plane, show that these points are collinear. How do you show? Just find the area of the triangle formed by these 3 points. If it is 0, that means they are collinear. Correct. This is the way. And find the value of b for which points 1 comma 2 minus 1 comma b and minus 3 comma minus 4 are collinear. Now he is telling these 3 points are already collinear. We just need to find the value of the b. Okay. So same way we just substitute all the values in the area of the triangle formula. Correct. And then where we have a b term here basically. So if you simplify, what you will get is absolute value of 4b plus 4 equal to 0, or 4b plus 4 equal to 0, b is equal to minus 1. Okay, this is how we'll calculate. This is one type of problems which you can see. Okay, now let's do this section. Verify whether the following points are collinear or not. We will find the area of triangle of all the 3 points given basically. Okay, first one is 0 we got, so they are collinear. Second question, we got the value area of the triangle as 3 by 2, which means they are not collinear. Okay, and third, 3 points basically we got 0 as the area of triangle, so they are collinear. Okay, so just be careful in the calculation. I have put the calculation here. Do it yourself first and then refer back. Okay, never ever look into the solution first solve it yourself and then look at the solution, whether if you have a doubt, that too. Okay, if you are assured that things are correct and you have a way to re-verify it, then do it first and then refer to the answers. Okay, let's learn the area of triangle Heron's formula. This comes in the geometry. Very easy, most of you have already learned anyway. We know the area of the triangle is half into base into height. Okay, at any, but only if three sides of the triangle are given, not the height, then how do you do it? Okay, so Heron has proposed a formula, Greek mathematician, which is here: a is equal to square root of s into s minus a into s minus b into s minus c, where s is equal to a plus b plus c by, okay, half of perimeter. S is semi perimeter basically, and then a is equal to square root of s into s minus a into s minus b into s minus c. Okay, this is a way. So the example is given: if the three sides are 12, 9 and 15 meter, using Heron formula, s is equal to 12 plus 9 plus 15 by 2, which is 18. So s minus a is 18 minus 12, 6, s minus b is 9, s minus c is 3. You substitute the values, area, okay, you will get 54 square meters as the area. So this is another way of calculating the area of the triangle. But if coordinates are given, I think the initial equation which we try to do it, this one is better, because you don't need to calculate three distances here, right? Here you need to calculate, if coordinates are given, you need to calculate A, B, and C, which again, as I said, involves square roots and squares, right? So yeah, you choose which one is easy, you feel easy, do this. Okay, let's do this. Okay, find the area of the triangle, the lengths of whose sides are 7, 24, and 25 meters. Okay, so A is this one, we know the formula, Heron's formula, and S is equal to 7 plus 24 plus 25 by 2, which is 28. So S minus A is 21, S minus B is 4, and S minus C is 3. You substitute the values, you will get 84 as the area, 84 square root as square units as area. Okay, yeah, other one. You don't need a Heron's formula here actually. Distance between 0 comma 0 and 4 comma 0 is 4. Distance between 4 comma 0 and 4 comma 3 is 3. Correct? You don't need the distance equation basically, right? Square root of y2 minus y1 whole square plus x2 minus x1 whole square. You don't require, because they are um, these coordinates are easy to calculate the distances. Okay, distance between 0 comma 0 and 4 comma 3 is, yeah, square root of 3 square plus 4 square, which is 5. Okay, now we have the three values. So okay, calculate the s, which is 6, and then other values, then area is equal to 6 square units. Area is 6 square units. Okay, now let's go to the exercise section. Okay, we already saw the template for this one, for the area of triangle, and the three vertices are given. So very simple, you just substitute the values carefully and find the value. Okay, area is 21 by 2. Second one, again same thing. You substitute the same template basically. You substitute the values carefully. That's all. Area is 32 here, square units. Okay. Then third one. These are all same problems, so I'm just skipping. Now find the value of k for which the points are collinear. Okay. We need to find the value of k. Okay. Third coordinates is not given, but he is telling that 3 points are collinear. So area of the triangle is equal to 0. That's what we will do, right? So for collinearity, area of the triangle is equal to 0. You substitute the values, okay? And what you will get is uh, 8 minus 2k equal to 0 or 2k equal to 8. K is equal to 4, okay? K value is 4. For the second problem, same way you will do, exactly same way. So you got 18 minus 6k equal to 0, okay? Or 6k equal to 18 and k is equal to 3, okay? Next. So here there are both x and y are k's. So you may get a different equation. That's all. Okay. So once you substitute the values, what you will get is 6k minus 14 equal to 0 or 6k equal to 14. K is equal to 7 by 3. Okay. Next question. Find the area of the triangle formed by joining the midpoints of the sides of triangle whose vertices are. Okay. Find the ratio of this area to the area of given triangle. Okay. So what they gave is uh, three vertices are given 0 comma minus 1 2 comma 1 and 0 comma 3. Okay, a triangle is formed and we are forming another triangle by connecting the midpoints of the sides. Okay, so first is area of the main triangle we will calculate, which is 4 units from the formula. Now midpoints of 0 comma minus 1 and 2 comma 1 is 1 comma 0. Midpoint of 0 comma 3 and 2 comma 1 is 1 comma 2, and other one is 0 comma 1. Now a triangle is formed by these 3 points. Now area of this one is 1 by 2 into same equation you will substitute, then you will get 1 unit. Okay. So area of inner triangle to main triangle is equal to 1 is to 4. Okay. So remember this will come in the geometry. If triangle is formed by connecting the midpoints of the sides of the triangle, then that area formed by that inner triangle is basically 4 times the main triangle. Okay. Basically, the inner triangle divides the main triangle into 4 equal parts. Okay. You should remember that. Okay. Find the area of the quadrilateral whose vertices are taken in the order given. Okay. We know how to find the quadrilateral area. You basically draw a diagonal and it will cut the quadrilateral into two triangles. Now you need to find the areas of two triangles and sum them up. So exactly same thing we have done here. Just to make sure that you have taken correct points A, B, D and B, C, D. If you really get confused, draw the quadrilateral here, then it's very easy for you. Okay, and the diagonal, okay, which points to take. So here the area of quadrilateral is around 28 square units. Next. Okay, fifth question. This is exercise part, not do this section. Sorry. Find the area of the triangle formed by the points, 3 points given. Heron's formula you have to use. So first is distance between this one. A is equal to 4 because I don't need to do square root formula here because y coordinates are same. So distance is only difference in x coordinates, right? Similarly, distance between 6 comma 3 and 2 comma 6 is I have to use the square root formula. So I got 5. Distance between 2 comma 6 and 2 comma 3 is x coordinates are same. So difference in y coordinates, that is 3. Now I have the three sides. I just apply the formula here, s equal to 6 and yeah, this is the value, right? Area of the square using Heron's formula is 6 square units. Okay, next let's learn the straight lines. Straight line. Okay, so we already had a class for the pair of linear equations. Okay, so there we know what is a straight line, right? Okay, a straight line is a equation of a straight line is in the form of ax plus by plus c equal to 0. Okay. If it is in this form, then it is a straight line. So we have the knowledge already. And how to plot a line on a graph paper also we have already seen. So let's just review it. Let's say this is a equation of a straight line 2x plus 3y equal to 0. How do you plot it on the graph? First, take some value for the x equal to 0. If you make x equal to 0, y is equal to 4. Okay. Similarly, x equal to 3, y is 3, and so on. You need 2 points, minimum 2 points to plot a line graph, right? So here he has taken 4, and you put those points on the graph paper in this order. You can see A, B, C, and D. Okay. If you draw the line, you can see it's a straight line. Okay. So this is a straight line. Now the question is, what you call this line? It's a line segment. Simple. And what are the properties of that? It is a straight line. It passes through all the points given here. Okay. It also makes an angle with x-axis as well as y-axis. Okay. Now plot these points on the coordinate plane and join them. Same thing. You just take the coordinate plane and put the points and draw the line. Okay. You can figure out easily which is a straight line, which is not. Okay. Now the question next, thinker discussion. This is important. He has given a equation y equal to x plus 7. Is this a straight line? It is a straight line. We already learned if it is in ax plus by plus c equal to 0 form, it is a straight line. So this is a straight line. We can draw easily. You can take x equal to 0, y is 7, x equal to 1, y is 8. So these 2 points are enough to draw a on the coordinate plane. Now, at which point this line intersects with x-axis? Okay. X-axis y coordinate is 0, correct? So if you take y equal to 0, x is equal to minus 7. So this line interacts with x-axis at minus 7 comma 0. Okay. And what angle this line makes with x-axis? Okay. This is important question. Our next section basically talks about it. That is slope. We call this as slope actually. Okay. The angle any line makes with x-axis is called slope. Okay. Tan of the angle basically is called slope. How do you measure? In a plane terms, you can take measurement instrument and you can measure the angle. Okay. But if coordinates are given, there is another way of measuring this angle. Okay. Let's learn that. So we call this, as I mentioned, as angle slope of the straight line. Okay. What is the slope of the straight line? Okay. If you see here, the given pictures here, uh, the second one is taller than first one. Okay, correct. So obviously you will slide faster on this because this is more slope, right? So each line, if you take two lines, they intersect with each other and then they make an angle. Correct. The line M makes a bigger angle. Okay, this angle is bigger than this angle. Correct. So once we know that angles are different, there should be a measure for angle. Correct. So the measure for angle is nothing but measure of the slope of the line. Okay. Now let's see the activity, how to go step by step and measure. Okay. This is the line, given line. Okay. And these are the coordinates which we have drawn for x equal to 0, 1, 2, 3, 4 and y is this one. And for every change in y, that means if you take here 2 minus 0, 2, okay, divided by change in x, 1 minus 0, which is 1. So 2 by 1, basically, right? 2 by 1 is 1. And similarly, here 4 minus 2 is 2, 2 minus 1 is 1. So 2 by 1 again. 6 minus 4, 2 divided by 3 minus 2, 1. Okay, or you take this 8 minus 2, 6 divided by 4 minus 1, which is 3. 6 by 3 is also a 2, right? So everywhere the change in y divided by change in x is always constant. Correct? Change in y is divided by change in x is always constant. This is called slope. Okay, the ratio is called slope of the line. This is the angle it makes with the x-axis, tan of the angle which it makes with the x-axis. Okay, how do you calculate change in y is y2 minus y1, change in x is x2 minus x1. So if you divide, basically what you will get is y2 minus y1, m is equal to, m is called slope. Slope of the line is y2 minus y1 by x2 minus x1. But if you see, this is a right angle triangle. Okay, this is if you call theta here, it is opposite by adjacent. Opposite by adjacent. Correct? Opposite by adjacent is called tan theta. Right? In trigonometry, you will know this is tan theta. So slope is nothing but tan theta. Okay, the angle it makes with the x-axis. If it is theta here, it is theta here also. Correct? Okay. So this is the concept of the slope of the line, and the slope is very useful when you solve several problems later actually. Okay, so this is very important concept. You have to know it. Okay, so slope is nothing but tan theta. This one is very important to remember. And how do you calculate the slope if 2 points are given? Y2 minus y1 by x2 minus x1. Okay, some example we'll do here. The endpoints of the line segment are 2 comma 3 and 4 comma 5. Find the slope. Slope is nothing but y2 minus y1. So 5 minus 3 divided by 4 minus 2, which is 2 by 2, that is 1. Slope is 1. Okay, let's do this section. Okay, find the slope of AB where A is 4 comma minus 6 and B is 7 comma 2. Simple equation. Okay, don't do any mistake. 2 minus of minus 6, that is 2 plus 6 divided by 7 minus 4. Okay, so 8 by 3. This is the slope. Second one, same template you will use. Okay, you get minus 1 as slope and minus 2 by 3 as slope. Okay, we'll come to the application of slope later. Okay, now try this section. Will go find the slope. We know we can do it very easily. We don't need to pen and paper. 6 minus 1, 5. 5 by 0. Is it possible? Okay, now that means this is parallel to x-axis. This line is parallel to x-axis. Correct? Same thing here. Okay, x coordinates are not changing. So which means x2 minus x1 you will get 0, which means this line is parallel to x-axis. Okay, same thing here. It's a parallel to x-axis. If a line is parallel to y-axis, then slope will be tan 90, which is 1. Correct? Sorry. Uh, I'm very sorry. There is a correction. If x-axis is not changing, that means it is parallel to y-axis. Okay, if x-axis x-coordinates are not changing, this is parallel to y-axis. Okay, if you just go to any graph paper, let's see. Okay, if I draw a line here, okay, every point on this line has a x coordinate as -6, doesn't change. Correct? So in this example, x coordinate is not changing, so which means these are all parallel to y-axis. Okay, if it is parallel to y-axis, you cannot calculate the slope because the tan 90 is infinity, basically 1 by 0, not defined. So we cannot calculate it. Okay. Now another section. Yeah. So here y coordinates are not changing. So it is 0 is the slope. Okay. Which is tan 0. This is parallel to x-axis. Okay. Because y coordinates are not changing. So it is parallel to x-axis. Okay. Now some examples here. Slope is a very small concept, but applications are good actually. Especially when you go to next level of classes, you will find lots of applications and a general equation also you'll find y equal to mx plus c, where m is the slope. Yeah. So with the slope, if the slope of two lines is same, basically, you can you can say that either they are collinear or they are parallel. If slope of two lines is same, okay, they are either collinear or parallel. Okay. If they have common point when you are calculating the slope, if they have a common point on both the lines, they are collinear basically. Okay. So lots of applications are there using slope. It's an important, very simple concept, very important. Determine x so that 2 is the slope of the line passing through this one. Okay, he is already telling slope is 2 and values are given. So y2 minus y1 by x2 minus x1 is minus 2 by x by 2, which is equal to 2. If I simplify, I'll get x value. Okay, so this is one simple type of problem which you can get in slope calculation. Okay. Now, let me just explain one thing which is not mentioned in the textbook actually. We can use slope to find if the lines are collinear, if the points are collinear basically. Okay. So how, if ABC are 3 points in coordinate plane, then we can say that they are collinear if slope of AB equal to slope of BC. Okay. Slope of AB equal to slope of BC. And you have to note down some important point here. There is a common point here, B and B common. Okay. B and B are common. That means I am drawing two lines from B which have same slope, which means they are obviously collinear. Correct? So let's say A is x1 y1, B is x2 y2, C is x3 y3. Then collinearity rule is, yeah, of course, you can take any three combination. Uh, I took AB and BC. You can take AC also. AB and AC also you can take. So y2 minus y1 by x2 minus x1 equal to y3 minus y2 by x3 minus x2. So you have three ways of finding three points are collinear or not. One is distance formula, other one is area of the triangle formula, third one is slope formula. Okay, so this is important one. That's why I just want to add this one slide for this one. You can use this for finding the collinearity also. Okay, next let's do the exercise. Yeah, this exercise part is very simple. First one is find the slope of given 2 points. So there are multiple points are given. All are same template. Just slope is y2 minus y1 by x2 minus x1, right? So I just did for all this. You can cross check. You can do it yourself and cross check the answer. Okay. Yeah. Next optional exercise. Center of a circle Q is on the y-axis. Center is on the y-axis. The circle passes through the points 0, 7 and 0, minus 1. If it intersects the positive x-axis at p, 0, what is the value of p? Okay. So we know that it is center is at on y-axis. That means 0, a. Okay. Distance between 0, 7 and 0, a is equal to distance between 0, 1 and 0, a, because 0, is center and on y-axis it is intersecting at 2 points. So these 2 points are the diameter. Correct. So 0, 7, 0, a is the radius and the same here also. So both radiuses are same. So if I simplify this, what I will get is a is equal to 25 by 8. Okay. And the radius is 31 by 8. Okay. Now distance between 0, 25 by 8, okay, which is center, and p, 0 is equal to 31 by 8, right? Radius. Okay. Now if I apply again distance formula, I can simplify it. I will get p square equal to some value and p is equal to square root of 117 by 8. Okay. Just do the calculation correctly. If I cross checked multiple times, check it yourself anyway. Next. Triangle ABC is formed by the points ABC. Okay. What is the point of intersection of side BC and bisector of angle A? Okay. Bisector of angle A. Okay. On to the side of BC. That means let's say AD is the angular bisector. If AD is angular bisector, okay, then what is the coordinates of D? That's what they are asking basically. Okay. Now we know that this angular bisector AD divides BC in the ratio of their sides. That is BD divided by BD east to DC is equal to AB east to AC. Okay, AB ratio to AC. That is BD by DC equal to AB by AC. Okay. Now we need to just calculate first AB by AC. Correct? So AB is there. AB is how many times AC? We can calculate. AB is here actually. AC is equal to AB is 2 square root of 13. AC is, just let me just correct it. AB is 2 square root of 13. AC is 2 square root of 10. So D divides BC in AB is to AC ratio, right? That is square root of 13 divided by square root of 10. Okay. If I substitute these values, what I will get is D value I will get on B and C. So this is the section formula which we are applying here. So this is the ratio we will get. Okay, you can simplify further, but this is the ratio. Okay, next. The side BC of an equilateral triangle ABC is parallel to x-axis. BC is parallel to x-axis. Okay. Find the slopes of the lines along with BC, CA and AB. Okay. BC is parallel to x-axis, so slope is 0. You know, tan 0 is 0. Angle is 0. And the slope of AB is AB will make 60 degrees with the x-axis, so tan of 60, which is square root of 3. Okay. And AC makes an angle of 120 degrees. Okay. Don't take 60 degrees. It is other side basically. 120 degrees. So tan of 120 degrees is nothing but minus cot of 30 degrees or minus square root of 3. Okay. So these are the slopes. Okay. Next. Find the centroid of the triangle formed by the line with coordinate axes. Okay. So this line basically is, this line is cutting the x-axis and y-axis, and it will form a triangle with origin. Okay. So one coordinate of the triangle is 0, comma 0, and the second one is you substitute x equal to 0. Okay. If you substitute x equal to 0, you will get y is 2. So 0, comma 2 is 1 point. And if you substitute y equal to 0, you get x equal to 3. 3, comma 0 is other point. So triangle formed by these 3 points, and the centroid is 1, comma 2 by 3. Okay. Next. Yeah, that's all. So this is all about the coordinate geometry section, okay, from the Telangana 10th class book. It has covered maximum points, and the only thing is they really introduced step by step how to derive a formula and come to the uh, uh, derivation of the formula. It is very interestingly derived actually. I think these are very good for the basic. Okay, you can learn further actually on the coordinate geometry. You can see lots of applications of slopes also. Okay, let's see what we have discussed. Okay, we discussed the distance between 2 points. Okay, in multiple ways, which are parallel to x-axis, parallel to y-axis, and not parallel to any of the axis. Okay, distance between any 2 points is, this is the general formula. Then we learnt about the section formula. Okay, if a point is dividing a x1 y1 x2 y2 in m1 is to m2 ratio, so this is the coordinates of that point which divides. Okay, if it is midpoint, obviously it is simple because it is 1 is to 1 ratio, so this is a simple formula. And this is the centroid of the triangle. Okay, if triangle is formed with x1 y1 x2 y2 and x3 y3, then centroid is this is the formula. Okay, next. Yeah, we know point divides the median in 2 is to 1 ratio is the centroid. Then we also learnt about the how to calculate area of triangle if three coordinates are given of the vertices. Then Heron's formula, then slope formula. Okay, these are all the things we learned, and it's all about doing more and more practice actually. Okay, don't limit yourself to the only 10th class textbook questions. There are very good questions in the NCRT exemplar, okay, which you can download online very easily. It's a free download. Okay, NCRT exemplar for 10th class you can download for each chapter. Coordinate geometry, trigonometry have separate books. It has variety of questions which you can solve actually. They are very nice to go to next level. Okay, and more practice. Maths is all about practice, practice, and practice. Okay, it's about finding a pattern and practice. Find a pattern, practice. These are the two things required for mathematics. Thank you.